Welcome to Networks Professionals.
Have you ever really wondered what's happening inside an AI's brain when it's learning? It kind of sounds like magic, but the truth is, it's a lot more like learning a craft. In this explainer, we're going to pull back the curtain and show you exactly how it all works. Let's get into it. So to really wrap our heads around this, we're going to use a simple, but I think pretty perfect analogy. Just imagine a brand new AI model, never been used before, is like an apprentice potter on their very first day. They're standing in front of that spinning wheel with a big lump of clay, and they have absolutely no idea what to do with it. And that's really the heart of it, right? That's the core question we're asking. How does that apprentice, or our AI, go from knowing literally nothing to being able to create something useful, maybe even something beautiful? Well, that journey, that's what AI training is all about. All right, so let's start at the very, very beginning. This is our AI's first day on the job. And just like any apprentice, it all starts with the raw material, that first lump of clay. So this very first step, it's called initialization. Basically, all of the AI's internal settings, we call them parameters, are set to completely random values. It is a total 100% blank slate. Think of it this way. Our apprentice potter, well, they don't have any muscle memory yet. Their hands are on the clay, sure, but their fingers are just in some random, totally uncoordinated position. Now, nobody, and I mean nobody, gets it right on the first try. The real secret to learning any craft, whether it's making pottery or machine learning, is just practice. And this brings us to the core of the whole process, shaping that bowl again and again and again, through trial and error and lots of tiny improvements. Okay, but to get better, you gotta know how you're messing up, right? In the world of AI, we do this with something called a loss function. Now, that sounds super technical, but it's just a fancy term for a tool that measures how wrong you are. For our potter, the loss function is like the master craftsperson looking at their first wobbly bowl and saying, the walls are too thick, the shape is all wrong, your error score is high. And this brings us right to the heart of the learning process, the training loop. It's actually a pretty simple 4-step cycle that just keeps repeating. First, the AI predicts, it takes a shot at making the bowl. Second, it measures the error using that loss function. Third, it optimizes. It figures out how it should tweak its internal settings to do a little bit better next time. And finally, it refines by doing the whole thing over again, and again, and again. So let's actually see this in action. The AI, with all its random settings, makes its very first guess. Our apprentice puts their hands to the clay and, well, hopes for the best. And oof, yeah, that's not great. The loss function spits out a really high error score. This is our lopsided, barely counts as a bowl first attempt. We are a long, long way from our goal. But here's where the magic really happens. The AI doesn't get frustrated, it doesn't give up. It takes that high error score and uses it as a roadmap. The optimization algorithm tells it, okay, to get that score lower, try adjusting your internal settings just this much in that direction. Okay, now let's hit the fast forward button. We're not talking about just 2 or 3 more tries. We're talking hundreds, thousands, sometimes millions of cycles through that training loop. So after 500 attempts, whoa, get this, the error score has absolutely plummeted. What's so amazing here is just the sheer scale of the improvement. Through all those tiny iterative adjustments, the AI has literally learned how to shape the clay. The bowl is now well formed. The model has become skillful. So we keep talking about the AI adjusting its internal parameters, but what even are those? Let's go inside the AI's brain for a second. Let's take a closer look at the potter's hands. The first type of parameter we need to know about is called a weight. The easiest way to think about weights is to imagine the specific pressure being applied by each one of the potter's fingers, right? To make a good bowl, some parts of the clay need more pressure, some need less. Weights tell the AI how much importance to give every single piece of information it gets. The second type is called a bias. Now, if weights are the individual finger pressures, you can think of the bias as the overall starting position of the potter's hands on the wheel. It's like a general offset that shifts the whole shape up or down, just helping the model get into the right ballpark to begin with. So here's a really crucial point. We need to separate what the AI learns on its own from what the human developer decides. Through that training loop, the AI automatically figures out the best weights and biases. Those are the subtle hand movements. But a human sets what we call hyperparameters. These are the rules of the game. Things like practice for 1 hour, or use this specific type of clay, or even how fast the AI should try to learn. The apprentice learns the feel, but the master sets the rules.
All right, so now that we get how an AI adjusts itself, let's talk about the different ways it can actually be taught. Because not every apprentice learns the same way, right? There are a few different teaching methods or styles of learning for an AI.
First up, you've got supervised learning. This is like the master showing the apprentice a picture of a perfect bowl and saying, make this. The AI gets data where all the correct answers are already labeled. Then there's unsupervised learning. Here, the master just dumps a pile of different clays on the table and says, sort these. The AI isn't given any answers. It has to find patterns and structures all by itself. And finally, there's reinforcement learning. This is pure learning by doing. The AI tries to make a bowl, and the master gives it a reward if it's good, or a penalty if it's bad. Over time, it develops a strategy to get the most rewards.
So, why do all these details really matter? Why should you care? Because this whole process, this is how we go from an inert lump of clay, a totally useless, random model, to a tool that is capable of incredible creation.
So let's just quickly recap the big ideas. First, please remember that AI learning isn't some single aha moment. It's a slow, steady cycle of practice and refinement. Second, the entire goal of this whole thing is to minimize error by constantly tweaking those internal parameters. Third, this is the very process that turns a generic blank slate AI into a powerful, specialized tool. And finally, the teaching method, whether it's supervised, unsupervised, or reinforcement, is always chosen specifically for the job at hand.
And all of this brings us to one last and I think critical point. We've seen how an AI is like an apprentice, and its skill is a direct reflection of its training, the quality of the clay, the guidance of the master. So that leaves us with a really important question to think about. If an AI's skill is shaped entirely by the data it trains on, what happens when that data is flawed or incomplete or biased? What kind of creation will it learn to make then?
Thanks for watching.